Hello, my name is Alex and I'm a Senior Solution Advisor for Rocket Software. So let's jump straight in. We can see that our application in this presentation uses ZOS Connect and it is acting as a server and running on ZOS. And the CICS program, which ZOS Connect calls, runs on CICS region itself. The client program is called catalog_v.10. Now, we have a slowdown in our application somewhere, but how we can investigate exactly where? So in today's demo, we will show you how you can detect your problem slowdown in your application using OMEGAMON AI for JVM and OMEGAMON for CICS, and how a more detailed problem identification for API is possible with combination of both tools. This slide also shows OMEGAMON AI for JVM ZOS Connect API provider summary screen, but we will go into more details for most of the tabs later on. So this is the first screen of OMEGAMON AI for JVM. So when you enter OMEGAMON AI for JVM, this is the first screen that you would see. You can see various pieces of information for both LPARS, RSO1 and RSO2 on my system. And you can see things like rate per minute, missed logs, and anything you can see in white is hyperlinkable, which means you can double click it and go directly into the screen that will give you more details of what we're trying to show you. So you can see on our RSO2, we can see that a red highlight, which is a threshold being tripped, that says 66%. And if you wanted, you could double click it and it will take you to the screen that will give you more details on the logs that were missed. But from here, we're going to drill down to the individual ZOS Connect server that we're working with today. I'm going to do a slash against RSO1. I'm going to do 5 for the JVM health summary. I could do the same just by typing S and hitting enter. And from here, I'm going to select our ZOS Connect server that we're working on and going to select 9 for a provider summary. So this is the same screen that we saw on the first slide previously. This is the ZOS Connect API provider summary workspace of the OMEGAMON for JVM. The API name tab displays the summary of the provider API issued of 5-minute period set for API name and HTTP method. In this environment, only the API catalog_v.10 is being executed by a GET method. In this workspace, you can also check the request count of the API, average, minimum, and max response times, their breakdown, a number of error APIs, number of APIs which have timed out as well. Let's drill down further and investigate our slowdowns and where the issue might be. The catalog API requests that invokes CICS transaction are sent to ZOS Connect, and the average response time for 13 requests is around 20 seconds. While the ZOS Connect time is around 0.0 seconds, while the SOR time is around 20 seconds, meaning that there is something wrong at the backend CICS application in our case and in our demo environment. We can also see that there's no error or timeouts as well. So now let's take a look at individual CICS requests for this API. In this screen, we can see the CICS transaction name, CSMI, which is our mirror transaction, and the name of the program, DFHOXCMN, which is the CICS sample vsum program. We can see that all of the requests showing similar request time. Let's check one of the requests in more detail by double-clicking it. The HTTP code, which is 200 and OK, indicating that the response time of this API is normal. We have OMEGAMON for CICS version 550 or higher. We can see the detailed CICS transaction tab called from this API in the same workspace. So from here, we can drill down further and investigate the poor response time. And from here, I'm going to hand over to Israel for OMEGAMON for CICS bit.
Thank you, Alex. My name is Israel Gross. I'm a Principal Solutions Advisor at Rocket Software. And again, what you've seen so far is we've taken a request that's come through ZOS Connect and connected to a backend system of record. In our case, it's CICS. It could have been IMS, for example. And because you have both OMEGAMON for JVM and OMEGAMON for CICS, you are able to click directly through on the transaction and take you to the task history detail for the particular transaction that is run. Now, this is kind of a summary of the details. On this page, you can actually see the same transaction ID, and you can see that the last program that was run, program ID, is DFH Z OMEGAMON. You can also see the terminal ID is a slash, which is usually used by ZOS Connect as the first character, followed by 3 digits. So if we were to click on the related tab, what you would see here, and this is normally what I would look at to solve a CICS related problem, is you would see all the transactions associated with this particular task. Just because it came from ZOS Connect and came into CICS through this particular region, which is FUW FWA1, doesn't mean that this is entirely where the transaction is run. If you've worked in CICS long enough, you'd know that transactions can run in multiple different CICS systems, each CICS system starting a new transaction, and they can all communicate with one another. So even though it looks like we're only using a single CICS region in this particular case, there could have been other CICS regions involved. And as a matter of fact, the problem could have been in one of those other CICS regions. But that is not our case. And because it's not, the next thing we would look at is the Programs tab. So the Programs tab is a feature that's available if enabled in OMEGAMON version 5.6, which will identify all the programs that were invoked during that pseudo conversation. Just keep in mind that, again, this is task history, so all these programs have run, and it'll show you the program name, how many times it was physically invoked, because it could be multiple times in a single unit of work, and then things like the CPU time, elapsed time, dispatch time, the CPU time on the QRTCB, the number of CICS calls, any abbends or TCB switches. And from this, it's quite intuitively obvious that that last program, DFH0 XCVDS, is the one that kind of has an elapsed time of 20 milliseconds. Now, I'd probably do some more research, so let's take a look at the IO tab and see if he's done any IOs, for example, in this case, VSAM IOs, and we can see that 3 requests were made. So let's double click on the VSAM, and it'll actually show you that which files were accessed and how many records or requests from each of those files had taken place. Now, again, you can see that those files are hyperlinkable, and if we wanted to, although we don't need to in this case, we can actually double click them and take us a little further. So if we were to hit PF3 and go back, since we know that there's some issue in terms of the time it took, let's take a look at the Timings tab. So the Timings tab in our case is going to show us quite literally that the reason for this delay is an interval control wait of 20 seconds. So as you can imagine, this is kind of a contrived example because somebody would have had to have issued some sort of a delay for 20 seconds, which delayed the task, which is why this took so long to run. But keep in mind, this would show us all the timings, where you might be waiting, if you were waiting on an external system, if you're waiting on I/O. And so this is where I would go if I noticed a response time problem, as we saw in this particular case. Okay. So keeping the related tab in mind and keeping the programs tab in mind, and the fact that you're looking at an entire logical unit of work is the way that I would identify what the situation was in this case that was causing the delay that was recognized within ZOS Connect. And now I'll turn it back to Alex. Thank you.
So just clicked PF3 and I went back from OMEGAMON from CICS into OMEGAMON for JVM. I'm going to do PF3 again and again. I'm going to go into the in-flight tab. So the in-flight tab provides you the details of the processes that has been started in the system but not yet completed. As you can see, there's one API which is currently in flight. And if we go and we double click it, we can investigate it further. While the request was running, we could see that there was a CICS tab as well. And once the in-flight task has finished, then the CICS details would be gone, and you would need to go through the API name to check for the CICS details. So this in-flight tab allows the user to see at a glance where the request is and where the request is actually stuck and move forward with the problem identification. Thank you for watching.